Hi guys, we're now in section 1.5. This section is all about story problems. So if you don't like story problems, well, we'll get through it somehow. Again, just another suggestion: draw pictures if possible. A lot of times it usually helps out. Okay, let's get started. All right, the first problem: the rectangular area is 375 square feet. If the length is 5 less than twice the width, what are the dimensions of this area? So I'm going to draw a picture first, just because I'm a visual learner for myself. So I know this is my length, this is my width, and I know the area is going to be length times width, and I know that is going to be 375. Okay? So here we got too many variables, right? You got well, I should say you have L and W. That's not going to help us out. And so we got to figure out something. So instead of having L and W, we can either only have L or only W. And that's when this comes in, right? The length is 5 less than twice the width. So what they're saying is length is twice the width, and then we take 5 away from that. So from here, I can replace the L with the 2W minus 5. So this is going to be 2W minus 5 times W equal 375. So 2W squared minus 5W is 375. And then we're going to set it equal to 0. Okay, in this case, I don't know if this is factorable or not. Usually the story problems that I try to give you something that's a little nice to work with. This one obviously not the case, so I'm going to use the quadratic formula just because I don't want to waste my time to see if I can factor this. So W equal negative 5, right? This is your A, B, C. Plus minus square root of negative 5 quantity square minus 4 times 2 times negative 375 all over 2 times 2. Okay. Again, grab a calculator. I'm not going to ask you to do this in your head because I'm using a calculator, so I don't expect you not to. So 5 plus minus 25 plus 4 times 2 times 375 is 3,000 over 4. So 5 plus minus square root of 3025 over 4. I'm not quite sure what that is. And this is 5 plus minus 55 over 4. Okay, I am going to ignore the minus because we're dealing with a measurement, actual length distance. Minus is no good, so this is going to be 60 over 4, which is 15. Okay, so the width is going to be 15. And that means the length is going to be 2 times 15 minus 5, so it looks like that is going to be 30 minus 5, which is 25. Okay, so the dimension is going to be 25 by 15 feet. That's going to be our dimension right here. Okay, again, draw a picture. Sometimes it helps. Don't try to keep the picture in your head. We can only remember so many things at a time, so put it on paper, a little easier to look at. I'm going to take a sip of my pop. Alright, let's move on to the next one. Okay, a piece of sheet metal 18 inches wide is bent to form a rectangular gutter. If the cross-sectional area is 36 square inches, find the depth of the gutter. So we have a piece of sheet metal like this, right? We know that's 18. And since we're trying to bend it into a rectangular shape, right? If we're trying to bend into a rectangular shape, that means these two sides has to be the same, and therefore the left on the bottom is going to be 18 minus 2x. Okay? So this is where we're going to get our rectangular shape from. So from here, we know, since we're given a cross-sectional area, so this area right here is 36 square inches. Okay, so that means we know that the area is going to be x times 18 minus 2x, and that's going to have to equal to 36. Okay. All right. So once we got our formula set up, let's go ahead and distribute. This is going to be 18x minus 2x squared equal 36. I'm going to rearrange things a little bit, set it equal to 0. So negative 2x squared plus 18x minus 36 equals 0. I also noticed that all my coefficients are even. So I'm going to divide by 2 to make my life a little easier. Smaller number means easier to work with. Instead of divide by 2, I'm actually going to divide everything by negative 2. Okay, if I do that, I get x squared minus 9x plus, let me see, 18 equals 0. Okay. And I think x squared minus 9x plus 18, from here you can use quadratic formula, or you can use factoring. I believe this is factorable. I think this is x minus 3, x minus 6 equals 0. I think that makes sense. Yeah, I think that makes sense. Yeah. Yeah, okay. So which means we know that x either equal to 3 or x equal to 6. Okay? Now, so in this case, we have two choices, right? Either we have a gutter that looks like 6 and 6, and this is going to be a, well, I guess you have 6, 6, and 6. Or you might have something that is 3, 3, and 12. Okay, and well, I guess either way works. But the thing is, realistically, a 12-inch wide gutter that might be a little weird. At least not the one you put on the house. So in this case, I guess we could have two choices, right? We can either have a 6-inch gutter or a 6-inch depth or a 3-inch depth. I'm assuming either one will probably work, depends on the application. But this is one of the questions that you're going to have multiple answers. So, alright, here we go. Next one. On the moon, the height of a golf ball hit with an initial velocity of 96 feet per second is given by the equation h equal negative 2.7 t squared plus 96 t, where h is the height, and after t second, and the t is the number of seconds after being struck. How long will it take the ball to hit the ground after being struck? So this is what I have imagined in my head, right? The ball getting hit. So the instant the ball get hit is when t equal to 0, and here is when the ball lands. So since we're talking about when the ball lands again, right? Which means we're saying that h equals 0, right? Because when you're hitting the ground, the height equal to 0. So I'm gonna set h equal to 0, And let's see if we can solve it. So in this case, I'm going to, you can do quadratic formula if you want. But in this case, I will probably just do factoring because I notice I can factor a t out. And notice, right, remember, if I have something times something equals 0, that means either t equals 0 or negative 2.7t plus 96 equals 0. Okay, now t equal to 0, obviously in this case not going to help us because when t equal to 0, that means you haven't hit the ball yet. So we're going to have to check this one out. Okay, so I'm going to put it on above because I run out of space. You're going to notice that I have somewhat of a poor space management, so don't be like me. Alright, here we go. Negative 2.7t plus 96 equals 0. So that means negative 2.7t equal negative 96. Divide both sides by negative 2.7. T equal, let's see what we got. Divided by 2.7. So roughly 35 and 1/5 second. Okay. So roughly it'll take about 35 and 1/5. Oh, sorry, not 1/5. My mistake. I don't know why I said 1/5. 5/9 of a second until the ball hits the ground. Your calculator shows 35.55555 and so on. So that's why you know that's going to be 5/9. Okay. Alright, Pat drives a tractor from one town to another, a distance of 120 kilometers. He drives 10 kilometers per hour faster on the returning trip, cutting 1 hour of the time. How fast did he drive each way? So, for this problem, right, we're dealing with speed, time, and distance. So we want to think about the formula. Distance is speed times time. Okay. So let's go ahead and figure out what else we can do based on this information. So when he's going to another town, right? And we know the distance is 120. We know this. He's got some speed going on. I'm gonna call it S. And which in this case, the question actually told us the speed is. Did it tell us the speed? No, it does not. So it's some speed and some time. Okay. Now on the way back, we know the distance is still the same, but this time we know the speed is 10 kilometers faster than returning. 10 kilometers faster on the return trip. So which means whatever the speed he has is going to be the going there and plus 10. Multiplied by the time returning. Okay? And the one important piece of information right here is this. Right here. Cutting 1 hour off the time. So what they're saying is the time returning is the same as time going minus 1 because it came back an hour faster. Okay, So from here, this is what our setup is going to be. Notice, there's a lot of things we can do here. For example, let's go ahead and solve for time in both equations. Okay, if you think about it, the time, if we solve for time going on the first equation, we can divide by s on both sides. So 120 over s equal time going. Same idea for the second equation. 120 equals s plus 10 times time returning. If we solve for time returning, this is 120 over s plus 10 equal time returning. We will take this and this right here and plug into our equation. So we have 120 over s plus 10 equal 120 over s minus 1. Okay. Now we have a workable equation that involves one variable. Okay. So this basically became a rational equation problem. I'm going to multiply by the CD, which is s times s plus 10, and I'm going to do that on both sides. Alright, so here we go. Let's go and finish this. If I multiply this out, I get 120 times s equal 120 times s plus 10 minus the quantity s plus 10. Okay. So this is going to be a little bit messy, but we'll get through it. So 120s equal 120s plus 1200 minus s squared minus 10s. Okay. So from here, notice we can actually kind of get rid of quite a few things here. Check this out. That can just be canceled out. Okay, so what we end up having is we have 0 equal negative s squared minus 10s plus 1200. Okay. In this case, I am going to multiply everything by negative 1. So I can get rid of the negative in front of the s squared. So 0 equal s squared plus 10s minus 1200. Okay. And in this problem, I happen to notice, hey, you know what? 1200, that's 40 times 30. So this is s plus 40 times s minus 30.
What?
So we have s plus 40 equals 0 or s minus 30 equals 0. So which means s either equal to negative 40 or 30. Okay. Now obviously we can't have a negative speed, right? So we know s has to be 30. Okay. All right. So once you figure out the speed's 30 and it's pretty straightforward, how fast did he drive each way? Well, that means on the way going, he went 30 miles per hour, and on the way back, he went 40 miles per hour. Okay, this one is a little messy and it takes a little bit of thinking, but it's not too bad. There is a different way that when I first did this problem, I actually tried a different way, and that was it got really messy really quick. So that's why I didn't do that way. But if you want to see how the other way is done, I can also show you. just ask me during our Zoom sessions. All right, next question. Okay, Bert and Ernie both invested some money. Bert invested $3,000 more than Ernie, and at 2% higher interest. If Bert received $800 annual interest and Ernie received $400, how much did Bert invest? Well, if you remember, I think we have done some problems with investing money. So just remember, interest is money invested times by rate. Okay. All right. So using that formula, so we know that Bert is going to be an Ernie. Right now, so if Bert invested X amount of dollars, right, and at some rate, I'm going to call it R. And the interest that he get is going to be $800. Okay. Now, as far as Ernie wise, now notice it says Bert invested $3,000 more than Ernie, so that means for Ernie is whatever Bert invested minus $3,000. And the interest rate, also noting, right? Ernie's interest rate is Bert invested at 2% higher, so which means Ernie's rate is going to be R minus 0.02. And that is going to get him $400. Okay? So check this out. We're going to use a very similar method like what we did on the last question. I am going to solve for R. Alright, sorry I had to step away for a little bit. Okay, go back. Solve for R. So we have let me see. R equal 800 over X. And this is going to be R minus 0.02 equal 400 over 400 over, sorry, brain fart, X minus 3,000. Okay, and if we actually we can go ahead now check this out, right? If we actually take this and plug it back in here, what we end up having is 800 over X minus 0.02 equal 400 over X minus 3,000. Okay, and another rational equation, so my common denominator is going to be X times X minus 3,000, and we're going to multiply that on both sides. Okay, alright, so we get 800, so once you distribute, we get 800 times X minus 3,000 minus 0.02 times X minus 3,000 equal 400X. We multiply that in. Clean things up a little bit. 800X minus 24, 1, 2, 3 with 5 zeros minus 0.02x squared plus 60, I believe that should be 1, 2, 1, 2, it should be 60x equal 400x. Okay. Clean everything up. I'm just gonna go ahead and move everything to the left. So I'm going to minus 400x on both sides. What you're gonna end up getting is the negative 0.02x squared. You're going to get 800x minus 400x is 400x, and plus 60x, so there's a plus 460x, and minus 2400000 equals 0. Okay, now once we get to this part, this is strictly, I'm just gonna use a quadratic formula to figure this out, because this is just, I really don't expect you to do with a factoring or anything like that. So I'm going to erase some of these. So and so give me a little bit of space. All right, here we go. So x equal negative 460 plus minus square root of 460 squared minus 4 times negative 0.02 times negative 2400000 over 2 times negative 0.02. So a little bit of work. Calculator says 460 211,600 minus 4 times 0.02 times 2, 4, 1, 2, 3, 4, 5 zeros over negative 0.04. So a little bit of extra spacing issues. I told you guys I'm pretty bad at space management. So 211,600 minus 192,000, you get 196,000 negative 0.04, which square root of 196,000 is 140. Okay, so in this case, let's double check our answers. So we get either negative 460 plus 140 over negative 0.04, or negative 460 minus 140 divided by negative 0.04. Again, more space needed. Alright, so which means, so if you did a negative 460 plus 140, negative 460 plus 140, you get negative 320 over negative 0.04. So divide by negative 0.04, you get 8,000. And if you do the other one, the negative 460 minus 140 and divided by negative 0.04, you get 15,000. Okay. All right, and I believe since we said what we said x was Bernie, correct? So that means either Bernie can invest 8,000 or 15,000. So that'll be our two answers right here. Okay. All right. Yeah, this one got a little messy, but we can do it. All right. It takes a little bit of practice. Get used to the format. Get used to the language, and I think we'll be okay. All right, the last problem. A hose can fill a swimming pool in 6 hours. Another hose needs 3 more hours to fill the pool than 2 hoses combined. How long will it take for the second hose to fill the pool? Okay, this one I struggled for a little bit because I was trying to do. Because of the typical problem they usually ask you is, if first hose can fill a pool in so many hours, a second hose can fill the same pool in so many hours, how long would it take for them to work together? So a lot of times you see these type of questions, but this one is slightly different. So it threw me for a loop a little bit, but we got to figure it out. So hopefully we can kind of follow along and figure it out how to work this. So the way I did this problem is I broke it down into the rate for each hose. Hose number 1. Okay, hose number 1 says it can fill the pool in 6 hours. So this implies 1/6 of a pool per hour. Okay. All right, and hose number 2. Okay, we have no idea how many hours it takes, so I'm calling it X. So this implies 1/X pool per hour. Okay. So check this out. So what about if we combine them? We have no idea how long it takes, right? But we know together it is going to be 1/6 plus 1/X. Okay. All right. So how is this going to help us? The other way you want to think is this. This is the idea we want to think. The work done is the rate times time. Okay? So if you think about how much work is being done, right? We know if you look at the hose number 2. Hose number 2, based on that formula, is 1 pool equal 1/X times time. Hose 1 plus 2, right? It's also gonna be one pool done equal the rate 1/6 plus 1/X multiplied by the time takes for hose 1 and 2 together. Okay, so how's that going to help us? If you solve for time on both of these, you get 1/X, you get 1/1/X equal time for hose 2, and you get 1/parentheses 1/6 plus 1/X equal time for hose 1 and 2. Okay, clean this up a little bit. Essentially what we have is this. You have time of hose 2 equal X, and time for hose 1 and 2 equal to this ugly looking thing. Okay, now the last piece of information we have is this right here. It says another hose needs 3 more hours to fill the pool than the 2 hoses combined. So which means the time for the second hose is going to be 3 hours more than the time of hose 1 and 2 combined. So this leads to x minus 1 over 6 plus 1 over x equal to 3. Because this is the time for the hose 2 and the time for hose 1 plus 2. Okay. Now we're going to have to clean this up a little bit because having a fraction inside a fraction is kind of messy. So a little bit of side work. The common denominator is 6x, so I'm going to multiply by 6x on top and bottom. Again, you can multiply by 1, right? In this case, my 1 is 6x over 6x. So I get 6x over, now if you distribute, you get x plus 6. So this is x minus 6x over x plus 6 equals 3. I am going to the common denominator in this case is x plus 6. So I'm going to multiply that on both sides. Okay. So we have x plus 6 times x minus 6x over x plus 6 equal 3 times x plus 6. So you get x times x plus 6 minus 6x equals 3x plus 18. Okay, so finish the problem. X squared plus 6x minus 6x equal 3x plus 18. This cancels out. So you get x squared equal 3x plus 18. Set it equal to 0. X squared minus 3x minus 18 equals 0. This is factorable. X plus minus 6, x plus 3. Okay, x minus 6, x plus 3 equals 0. So this means x either equal to 6 or x equal negative 3. Now, we cannot do, in this case, this is extraneous because you can fill negative amount of time. Right, that is extraneous. That's no bueno. So only number we can use is 6. So you'll take 6 hours for hose 2. Okay. Yeah, the story problems can be a little weird. But I think these should be some pretty good ones that should kind of get you started. If you have any questions, no, definitely feel free to ask me on the Zoom sessions. Again, email whsieh@grcc.edu or 616-234-4729. Or you can catch me on the Zoom meeting. We have every office hour that we have every day from 6 p.m. to 8 p.m. Monday through Thursday. Okay? And if you really need help, also check out the math lab. Right, the math lab is open, and the tutors in there are very capable. So if you are stuck during the day, hit them up. Okay? All right, we'll talk to you later. Bye-bye.